Hello, curious minds, and welcome back to our audio adventure. Today, we're diving into a topic that feels like pure magic, but is actually a brilliant piece of engineering: how computers understand us when we talk or type.
Yeah, it really does feel like magic sometimes, doesn't it, Jamie? I mean, I can just say, "Hey computer, what's the weather?" and it just knows. Or I type a message in one language and it instantly translates it into another. It's wild.
And it absolutely is. And for many years, understanding human language was one of the biggest challenges for artificial intelligence, or AI. It's called natural language processing, or NLP for short, and it's how our digital helpers make sense of our world. But here's the big secret, Alex. AI doesn't understand language the way you or I do.
Wait, hold on. It doesn't? So when my phone says, "Okay, here's the forecast," it doesn't actually know what a forecast is? Or what cold means? My mind is a little blown right now.
Not in the human sense of knowing, no. It doesn't have feelings or experiences. It hasn't shivered in the cold or celebrated a sunny day. Instead, AI uses a truly remarkable trick. It understands our words by looking for patterns and learning from tons and tons of examples. Think of it like a master detective, not understanding the emotions behind a crime, but meticulously piecing together clues and patterns to solve it.
A master detective. I like that. So it's not really thinking like a person, but it's incredibly good at recognizing things.
Exactly. Let's try a simple analogy. Imagine you want to teach a young, bright person to recognize different types of fruits. You wouldn't just give them a textbook definition of apple or banana. You'd show them an apple, point out its red skin, its round shape, maybe even let them taste it. Then you'd show them another apple and another. Then you'd show them a banana, yellow, curved. You'd keep showing them, right?
Definitely. The more examples, the clearer it becomes.
Right. After seeing hundreds of apples and hundreds of bananas, your curious friend starts to notice patterns. Okay, red and round often means apple. Yellow and curved, that's a banana. They're not reading a definition, they're building a mental library of features and patterns from the examples you provided.
So the computer is like that curious friend, and all our conversations and texts are the fruit examples it's seeing.
You've got it. Now, let's take that idea and apply it to language. When AI is trying to understand, say, "I want to eat ice cream," it's not actually picturing a delicious scoop of ice cream. What it's doing is recognizing patterns it's learned from countless other sentences. It's seen millions of sentences where "I want" is followed by something a person desires. It's seen millions where "eat" is linked to food. And it's seen millions where ice cream is a specific type of food.
So it connects the dots based on all the times it's seen those words and phrases together, like a super fast puzzle solver.
Precisely. Let's switch our analogy a bit to make the how even clearer. Imagine you're a brilliant chef learning to cook for the very first time. You don't know what sweet or savory truly mean in an abstract sense, but you're given hundreds, even thousands of different dishes to taste.
Oh, this sounds like a dream job.
It really does. Now, as you taste, you also get to see the ingredients and the steps used to make each dish. You taste a strawberry cake and you see flour, sugar, strawberries, eggs. You taste a savory soup and you see broth, vegetables, salt, herbs. You don't know what sweet inherently is, but you start to notice a pattern. Dishes with sugar in them often have a certain taste. Dishes with salt have another kind of taste. You learn the connection between ingredients and the resulting flavor.
Ah, so the AI is like that chef. It's not born knowing what a request is or what a command is, but it learns by tasting, or, well, reading, millions of recipes of language.
Exactly. And this process is what we call training the AI. It's a bit like a sports coach training a team. A coach doesn't just tell their players, "Go win the game." They show them hundreds of plays, explain strategies, drill specific movements, and then let them practice. Over time, the players learn to recognize patterns in the game: when to pass, when to shoot, when to defend. Not not because they've read a book about the philosophy of soccer, but because they've practiced and observed countless examples.
Okay, so the core idea is patterns plus examples. Lots and lots of examples. But how does it actually do that? How does it see patterns in words?
Excellent question, Alex. This is where the methodology comes in. Let's break it down into a few steps using our chef analogy. Think of it like building a fantastic meal from scratch. Step 1. Gathering all the ingredients, the data. Before our chef can learn, they need to taste dishes, right? For AI, these dishes are massive collections of human language. We're talking billions of words, sentences, conversations, articles, books, and web pages. These are gathered from all sorts of sources, completely anonymized and respecting privacy, of course.
So it's like collecting every recipe ever written in every language and putting them all in one giant cookbook.
That's a wonderful way to put it. And not just recipes, but grocery lists, cooking blogs, restaurant reviews, everything related to food. The more diverse and comprehensive the ingredient list, or in our case, the language data, the better the AI can learn. Step 2. Tasting and learning, finding the patterns. Once our chef has their vast collection of recipes, they start tasting. They might notice that whenever they see sugar, the dish is usually sweet. When they see chili pepper, it's often spicy. They start to build connections. Sugar often pairs with sweetness, chili with spiciness, flour with baked goods. These are the patterns they're identifying.
So the computer is tasting all those sentences and noticing, hey, these words tend to go together, or this type of sentence usually means a question.
Exactly. For AI, this involves really complex mathematics and algorithms. It's essentially identifying how frequently words appear near each other, in what order, and in what context. For instance, it might learn that if it sees the words what, is, and whether, there's a very high probability that the speaker is asking a question about the current atmospheric conditions. It's also learning the relationships between words. It might learn that apple and banana are both fruits, and run and walk are both movements. It creates a giant invisible map of how all words and concepts relate to each other, based solely on how they've been used in the vast sea of data.
Okay, so it's not just single words, but phrases, and even the way sentences are put together, like the grammar and flow.
Absolutely. It's like our chef not just noticing ingredients, but also noticing cooking methods. Baking usually involves an oven. Frying involves a pan and oil. The order of operations, the structure of the recipe, is just as important as the ingredients themselves. For language, this means understanding things like sentence structure, verb tenses, and even identifying the main subject and action in a sentence. It's building a massive, intricate pattern book for every aspect of language.
Wow, that's a lot more detailed than I imagined. So it's constantly refining this pattern book as it sees more and more language?
Precisely. It's a continuous learning process. The more data it processes, the more robust and accurate its pattern book becomes. Step 3. Cooking a new dish, making sense of new language. Now our trained chef has their mental pattern book. When you ask them to make something new, like a sweet fruity dessert, they don't need a specific recipe for that exact dish. They can combine what they've learned. Sweet means I should use sugar or honey. Fruity means I should add berries or apples. Dessert implies it should be baked or chilled. They use their learned patterns to create something new that fits the description.
So when I say, hey computer, play some happy music, it doesn't have that exact phrase in its memory, but it uses its patterns to figure out what play, happy, and music mean in combination?
You've nailed it. When you say, hey computer, play some happy music, the AI first breaks down your request. It identifies play as an action, music as the object of that action, and happy as a descriptive quality. Then it refers to its internal pattern book. It knows from millions of examples that play music is often a command to start an audio stream. It knows that happy is an emotion, and it likely has categories of music tagged with emotions. So it combines these learned patterns to deduce The user wants me to find and start playing music that is categorized as happy.
So it's like it has a giant mental dictionary, but instead of definitions, it has probability scores and relationships for everything.
That's a great way to describe it, Alex. It's not a dictionary of meanings in our human sense, but a dictionary of relationships and likelihoods. When it sees a new sentence, it doesn't understand it, but it calculates the most probable meaning based on all the patterns it's learned. This is why these systems are so powerful for things like translation, chatbots, and voice assistants.
Like, for translation, it's not learning one language and then another, but it's learned the patterns of how ideas are expressed in language A and how those same ideas are expressed in language B. And it finds the most probable match?
Exactly. Imagine you've learned to recognize the ingredients and cooking steps for both French cuisine and Italian cuisine. When someone describes a dish in French, you can map those ingredients and steps to their Italian equivalents, even if you don't speak French perfectly. You're translating the patterns of the dish, not just individual words.
That makes so much more sense. It's not translating word for word, but idea for idea, based on learned patterns.
Precisely. And this is why the more data, the better. The more examples of French and Italian dishes our chef tastes and analyzes, the better they become at translating a French description into an Italian one, capturing the true essence of the dish, not just a literal translation.
So when I interact with a chatbot, or ask my voice assistant a question, or translate a web page, it's all thanks to this pattern matching skill?
It truly is. These systems are constantly processing new language data, refining their patterns, and becoming more accurate. It's a continuous cycle of learning from experience, just like a human chef who constantly experiments and learns new techniques.
It's still incredible that it can do all that without actually, feeling or thinking.
And that's a crucial distinction, Alex. AI is a tool, a very sophisticated one. It's fantastic at recognizing patterns and making predictions based on those patterns. But it doesn't have consciousness, emotions, or an understanding of the world in the way we do. It's like a calculator that can do incredibly complex math, but it doesn't understand what numbers mean or feel the joy of solving a tough equation. It's purely performing computations based on its programming and the data it's been trained on.
So it's a super smart parrot, not a human brain.
In some ways, yes, a very, very sophisticated parrot. One that can mimic and combine patterns it has observed to produce novel, seemingly intelligent responses, but without the underlying subjective experience or understanding. It's pattern recognition on a grand scale.
This has totally changed how I think about my smart speaker now. I used to think it had a little brain in there, but it's actually more like a pattern-detecting super sleuth.
A super sleuth powered by mountains of language examples. And that's what makes natural language processing so powerful and so fascinating. It allows us to interact with machines in a way that feels natural to us, even if the machines themselves are operating on a fundamentally different principle.
So, to recap our journey, the big idea behind AI understanding our language, or natural language processing, is that it doesn't understand like a human. Instead, it's a brilliant pattern matcher. It learns by observing countless examples of human language, sentences, conversations, texts, much like a chef learns to cook by tasting many dishes and seeing their recipes. It identifies the connections and likelihoods between words, phrases, and structures. Then, when it encounters new language, it applies these learned patterns to predict the most probable meaning or generate a relevant response, just like our chef can create a new dish based on their understanding of flavors and techniques.
And it's all about collecting huge amounts of examples, finding the connections and patterns within those examples, and then using those patterns to figure out new situations. It's amazing how something so complex can be broken down into such a clear, logical process.
It truly is, Alex, and it's a testament to the ingenuity of how we're learning to build these incredible digital tools.
Well, Jamie, this has been an incredibly insightful journey into how computers hear us. My mind definitely feels expanded.
Mine too, Alex, just thinking about it. And to all our curious minds out there, thank you for joining us on this exploration. We hope you feel a little more connected to the fascinating world of AI and language.
Keep asking those questions and keep exploring.
And we'll catch you next time.